Alright guys, welcome to the first video that we're going to be covering this semester, this term, this school year, and we're just going to take it easy for the first week and talk about linear equations. So you should already be familiar with most of this information, but a good review is a good review. We're going to be reviewing linear equations, and before we talk about linear equations, I want to make sure that we all understand the fundamental basic of what a function is. So, by definition, a function is a relation from a set of inputs to a set of possible outputs, where each input is related to exactly one output. So, let's break that down so that hopefully it actually makes sense, because I'm sure it didn't. So, we're going to be talking about, of course, the linear function. That is what a linear equation looks like. So when we say in the equation that we're going to analyze that a function is a relationship between two variables, that's essentially what it's saying. So most of the time those variables are x and y. X and y. So what is our input and what is our output? So when you see f of x, or your y values, when we say f of x, it's pretty much saying y. We use that interchangeably a lot in math. So y, or your f of x, is known as your set of outputs. As your set of outputs and is your dependent variable. Your x, on the other hand, this is your set of inputs and the independent variable. So what does an input and an output actually mean? If we were to go ahead and make a table, let's just say we are making a table of our f of x equals x function, x and f of x. Well, if we wanted to figure out what any value of f of x is, we would have to input a value into the function, right? Well, there you go. You have our input right here. X is going to be our input value because that is what we're putting into the function. And then whatever our equation comes out to be, that's our output. So that is what f of x equals, right? So let's just say if we wanted to see what 0 is in this equation. So if x is 0, that is our input. And if we put that into our function, so wherever there's an x, we're going to put a 0. Now this is pretty straightforward because this is the most basic linear function, but we'll go over in a little bit different versions of this function. Well, if we put in 0 into our x value, our f of x value is going to equal 0. So that's our output. So our input is 0 and our output is also 0. Now let's just say we want to do 2. Well, f of 2 is going to equal, again, we're going to put in 2. Well, that's just going to be 2. So our output is also 2. So when x is 2, our y is 2. When x is 0, our y is 0. Let's try a negative number now. Let's say negative 1. So our input value is negative 1. And what do we get out of it? We just get negative 1. X is negative 1. Our y is negative 1. So if you do this for every possible value in your domain right here, for every possible x value, if you were to put every possible x value into your equation, well, you would get a line, or you would get a bunch of dots that look like this, that form that linear pattern like that. So that's why we call it a linear function, because it's just a straight line. So that is what a function basically is. It's just describing the path, the relationship of two variables. And these variables can describe many different things. You could have your x variable equal time and your y value equal distance. So you can compare or describe the relationship between a car that travels along a road. After 5 minutes, 4, 3, 2 minutes, how far has it gone? Does it form a linear path like this one? You could also say that your x value is your weight and your y value is your height, and you want to try and see what the relationship is between people's height and their weight. See if there's a relationship between the two. Say maybe the taller you get, the more heavier you are. But that is what a function is. Describing a relationship between two variables, a set of inputs and a set of outputs. Also notice up here, it's also important to know that it says each input is related to exactly one output. So what does that mean? Well, it means that for whenever you have an input, it can't have two output values. So if I had, let's say, if x was 0, let's say for some weird reason that I got another, let's say I got 3. So when x was 0, y was 3. But then up here, we already have x value when x is 0, that our y value is 0. So pretty much what we're saying is that you can't have an input value come out and have two output values, because then you're going to run into something weird like this. If we were to put this in terms of a real life example, like time versus distance. So if we said that this was your car traveling, and at 2 minutes you went, I don't know, 2 miles, but then let's say you had another output function, it's not possible for you to be also at 4 miles at 2 minutes, right? You can't be in two places at once, right? So that's kind of just an example of what it means to not have more than one output. A function doesn't have two outputs for one input value. So that is what a function is. So hopefully that makes sense. Okay, this information should just sum up what we just talked about, but you can go ahead and read over it if you want. So over this course, we are going to cover different types of functions. So not all of them are going to be functions that follow in a straight line. We're going to cover exponential functions, quadratic functions, log functions, different kinds of functions. And functions help us describe different ways, different relationships between the two variables. Because not every two variables is going to follow a linear sort of a pathway. But for now, let's just focus on what we know with our linear functions. So functions usually have a general form, and then it will have a form you can make changes to. The general form of functions we call the parent function. And when there are changes made to the function, we call those functions family functions. So the parent function of our linear function is f of x equals x. This is the parent function of a linear function. Now you can make changes, or we call them transformations to the functions, right? We can move this linear function up and down, left and right. We can also change it so that the line isn't going directly at a 45-degree angle. It can be going steeper or it can be going more shallow. So we call those transformations, and whenever there's a transformation, we call those functions family functions. So oftentimes you will see a linear function in standard form or slope-intercept form. Standard form comes around every so often, but slope-intercept form is a more common way to show what a linear function is, because it states the m and the b value. M is your slope, and b is your y-intercept. And it's much easier to identify these values if it's in slope-intercept form. So, we're going to go over a couple examples. And with these four equations, what we're going to do is identify our slope and our y-intercept. And we're going to identify them by using m and b. So, y equals 3 over 2x plus 8. Let's go ahead and write down our slope-intercept form. Well, this looks awfully familiar, right? So this would be our m value, and this would be our b value. So m is equal to 3 over 2, b is equal to 8. And this one, m is equal to 13 over 11, b is equal to 12 over 11. Now, this one we have negative signs, and negative signs matter. It will change what our function does. So we include them. So m is equal to negative 6 over 5, b is equal to negative 3. Here, m is equal to 4, b is equal to negative 1. So as long as your function is in slope-intercept form, it's pretty easy to identify your slope and your intercept. Now, in these ones, 1 through 6, what we're going to do, we have the slope and the intercept provided. Now let's just go ahead and write it in the equation form. So again, we're going to write our equation. F of x is equal to mx plus b. So our slope is equal to m, y-intercept is equal to b. So f of x is equal to 0x plus 9. Now right here, we can shorten our equation. F of x, 0 times x is just going to be 0. So that just goes away entirely. So our function is just going to be 9. It's a constant function. It's not going to have any slope. Our slope is 0. So our slope is going to be totally flat whenever y is equal to 9. Totally flat. So for every x value, for every input value, our output value is going to be 9. Okay, let's go to number 2. F of x is equal to negative x plus 0. Again, we can rewrite this because there is no y there. The y-intercept is just going to be at the origin of 0, 0. So we can just write negative x. Here, f of x is equal to 2 minus 3. Minus, because we have a negative number. Sorry, I need my x in there. Okay, for 4, f of x is equal to negative 3x plus 7. 5, f of x is equal to 4x minus 2. 6, f of x is equal to 1 over 3x plus 2. So it should be pretty easy whenever you understand where your values need to go. Alright, so for these ones, we're going to graph our equations that we had for 2, 3, and 5. So starting with 2, we said f of x is equal to negative x. So one way you can go about this is you can go ahead and create your table of inputs and outputs. So our inputs and our outputs right there. So let's go ahead and, I always like starting with my 0 values because it's just easy. So if I put 0 into our function, f of 0, it will output negative 0. Negative 0. And I always like to put parentheses around the x value that I'm inputting. Well, negative 0 is just 0, so our output value is 0. Let's go ahead and graph a negative number. Say f of negative 3. Well, that's negative 3. Well, this is really outside, this is saying negative 1 times by negative 3. Negative number times by negative number is a positive number, and negative 1 times by negative 3 will be 3. So when x is negative 3, y is 3. Right there. X negative 3, y is 3. Alright, let's try a positive value, which is going in the other direction, f of 3. So we get negative 3, well that's going to be negative 3. So when x is 3, y is negative 3. Let's go ahead and connect the dots. It's pretty easy right now because again it's a linear function. So there you go. So this looks like our parent function, except that it's going in a different direction, and that's because it's negative. So this has a negative slope rather than a positive slope. Negative slopes will start kind of up here in this region and go in a direction in the bottom right direction. Okay, so that's one way you can go about it. Here, sorry, 3 and negative 3. So to move on to our next equation that we're going to graph, number 3, f of x is equal to 2x minus 3. All right, I'm going to go ahead and do one more table. We have our inputs and our outputs. Let's go ahead and start with 0 because that's always the easiest. So f of x f of 0, our input value is equal to 2 times by 0 minus 3. Well, 2 times by 0 is just 0. So this is going to equal negative 3. So when x is 0, y is negative 3. And look, we could already tell that by looking at the function, right? Because we said that this value right here is our y-intercept. This is our y-line, right? And that's where our function is going to cross the y-axis, is at negative 3. So let's go ahead and do 1 right here. F of 1 is going to equal 2 times by 1 minus 3. So it's going to equal 2 minus 3, which is equal to negative 1. So when x is 1, y is negative 1. Let's do negative 1 now. So f of negative 1 is equal to 2 times by negative 1 minus 3, which is equal to 2 times by negative 1 is negative 2 minus 3, which is equal to negative 5. So when x is negative 1, our y is going to be negative 5. Alright, so now it should be pretty straightforward on how we can connect our lines and graph our function. Let's see. Just like that. Now, something that I want to point out is the slope in this one. So you might have heard people say that slope is equal to rise over run. And I hope you already know that at this point, and I think you should. So in this case, we said that our m is equal to 2, right? Just remember that anything divided by 1 is itself. So we could say that this is really 2 over 1, because 2 divided by 1 is 2. So this would be our rise, and this would be our run. So rise is up this way, and our run is over this way. So you can see that from every x value, we are going from one x value to another, we are going up 2, our rise is over 2, and our run is over 1. Up 2 and over 1. Up 2 and over 1. So there you have it. That you can see that our graph that we have has a slope of 2 in a positive direction. Okay, so for number 5, we have x equals 4x minus 2. F of x is equal to 4x minus 2. Now, instead of actually plotting points by making an input and output table, let's just go ahead and graph this, knowing that we have a y-intercept of -2 and a slope of 4. Remember that this is equal to 4 over 1, which is equal to our rise over our run. So let's start with our intercept. So our y-intercept is -2. So on our y-line, our function is going to cross that -2. So we already have a point there. And now we can use our slope to figure out the rest. We said that the rise is 4, 1, 2, 3, 4, and the run is 1. So there you go. We already have our 2 lines that will help us plot this, draw this linear equation. Just like that. So you can see here that if we were to continue our slope, we'd go 1, 2, 3, 4, and over 1. Or over 1 and 1, 2, 3, 4. So you don't always have to just use a table. If you have your slope and your y-intercept, you can just go for it and probably save you time. But also, the table helps you understand and helps you see inputs versus outputs to see the relationship. So I hope that was a helpful review. Again, if anything didn't make sense, please go back over this video, try and understand some parts that you might not have caught before, and then come to class with some questions, and we'll have a discussion about it. All right, guys.